ka. Ay, hindi siya naka-full screen. Teka lang. Okay. So last time I gave you an assignment and hopefully nasagutan nyo siya. And that assignment was a strong acid, strong base titration, right? Okay. So I have the answer here. Wait lang. Strong base, strong acid titration. So this is the answer. I hope you got these answers here. No? So we start with the pH of 12.4 and then it's going down to 2.51. Sana yan yung sagot nyo. Kung walang sagot, kayo bahala. No? Mas maganda na yung nagpa-practice ngayon pa lang. No? Okay, so yan. Yan yung sagot for each stages. Okay. So hopefully you get the correct answer and yung graph, sana ganito yung nagawa nyong graph. No? Okay. So yan. Okay. So kung meron kayong mga questions about the previous discussion, sabihin nyo na ha, para tuloy-tuloy tayo. Okay, so last time we were able to cover strong acids, strong base, and strong base, strong acid titration calculation. So the equations are ano naman, easy to understand. Basically, what we are doing here is that we are monitoring the changes in the concentration of the H plus or the OH minus. No? And the concentration of them can be deducted from the changes in the moles of a substance. No? Okay? So alam nyo na bakit ganyan yung equations natin. No? Okay? So we will proceed with the next part, the weak acid strong base titration. Okay? So when we have a weak acid strong base titration, kung sino yung nauna, siya yung analyte. So that means ang WA ay weak acid. Okay? So we have a weak acid as the analyte and the strong base as your titrant. No? So rule of thumb, no? So pag sinabing weak acids, no? Ito ay may mga Ka values, okay? So basically sila ay may mga Ka values, okay? So kailangan alam na natin paano i-differentiate yung strong acid sa weak acid, no? So one of the ways to discriminate the acids is in terms of their dissociation. Kapag weak acid may Ka, pag strong acid full dissociation kaya hindi kailangan ng Ka, no equilibrium. Ikalawa, if you know the chemistry of the molecule, no, you can actually determine if a molecule is acidic or basic depending on the structure, no. Although di ko na to na-discuss sa inyo kasi hindi to i-cover, pero in chemistry, pag BS Chem, there are many factors that affect the acidity of a molecule. For example, the presence of electron withdrawing atoms such as oxygen, nitrogen, so on and so forth. No? Okay? So, yun yung mga factors that affect the acidity of a molecule. Pero for our class today, basta may Ka, weak acid. Okay? So, yun. So, sana mabilis agad yun ma-recognize. Okay? So yan. Pag sinabing strong base, ito yung mga bases that are fully dissociated. So technically, sila may group 1 hydroxides, no? Group 1 hydroxides and barium hydroxide, no? And the other hydroxides ay precipitates, no? Okay? So yun yung idea. Okay, so again, this is similar with SASB and the SBSA titrations. We still have the 4 stages, no? We have the initial, the pre, the equivalence, and the post-equivalence point, no? And for each stages, there is a corresponding equation necessary to compute for the pH of the solution. Okay? And the equations we have here on the right side is derived from the equilibrium system. Bakit may equilibrium, sir? Kasi we have a weak acid, no? Remember that when weak acid dissociates into ions, it is in equilibrium state, no? Ibig sabihin, we should follow equilibrium concept, no? Kaya may makikita kayo square root of tsaka, so on so forth, no? Alam ko, alam nyo na, pero uulitin ko uli yung idea dito. Okay? So, let's start. So initially, since ang ating analyte ay weak acid, that means in our solution or in our Erlenmeyer flask, we only have water and the HA, the weak acid HA. So, of the two species, sino ang magko-contribute sa pH ng solution? C, weak acid. Okay? Because the weak acid is stronger than the water. Okay? So, mas strong ang weak acid kaysa sa water. So, that means the pH of the solution is reliant on your acid strength. No? Okay? So, what we know is that when your acid, your HA, no, is in the solution, it dissociates into ions, di ba? So we produce H plus or H3O plus and the conjugate base. No? And take note that this is acid dissociation equation because we produce H plus on the right side. So ibig sabihin this is Ka. So we write it as H plus A minus divided by HA. Using ice table, we can use a dummy variable x to solve for the equilibrium concentration. So this will be x, this will be x. This is the concentration of acid minus x. And using the small x approximation, assuming that the ratio of the concentration and the Ka is greater than 1000, we can remove this. No? We can remove this negative, the minus x in the denominator. So that means the equation can be written as Ka equals x squared divided by Cha. Solving for the value of x will give us the square root of tsaka. Naalala? Ayun. Yan yung reason bakit yan yung equation natin because we are solving for the initial concentration of H plus. No? And that is given by the square root of tsaka. We already know that because we discussed ice table last time. Okay? So, hopefully clear bakit ganyan na equation dyan. Okay. Next, after the initial, we have the pre-equivalence point. What happens here is that you are now adding titrants. Nagdadagdag ka na ng base. What happens when you add base sa inyong acid? Nagre-react sila. Okay? So when you add titrant to your weak acid, what happens? Okay. So slowly, yung ating weak acid, na-convert siya into salt, no? And water. Okay? So yun yung idea. When we add titrant to our acid, that means nababawasan yung acid natin. And some of them are converted na into the moles of conjugate base, no? And again, whenever you have a solution with a conjugate base acid pair, that means we are in a buffer region. So nasa buffer region tayo kapag mayroong pag meron tayong weak acid and a conjugate base pair. So recall that every time we have a buffer system, we have to use the Henderson-Hasselbach equation. Okay. So we have to use the Henderson-Hasselbach equation, which is given as pH equals pKa plus log conjugate base divided by the concentration of the acid remaining. Okay? Nag-emphasize ako doon, no? Remaining concentration of acid. Bakit? Kasi nga, nababawasan na siya. Kaya nga sabi ko doon, less eh. So, ibig sabihin, you have to determine how much acid is left. O how? Paano nga ba? To determine the remaining concentration of acid or to determine the remaining amounts of the acid, we can use the mole acid minus mole titrant or the mole base. Okay? So, ganun lang. Mole acid minus mole base or the mole of your titrant. Okay? So, ano yung acid natin? Analyte. So, let me erase this again. So, ang acid ay analyte. So, to express the mole of the acid, that's MAVA. Okay? Molarity analyte times the volume of analyte. And to express the mole of the base added or the titrant, that's Bakit hindi molarity? Okay? Kasi ganito. If you are in the same solution, ang volume ng dalawa ay same. Ang volume nito at yung volume nito same. Total volume eh. Pwede may cancel yung volume, so you will be left with moles. Okay? So instead of using molarity, we will now use moles na lang. Okay? So moles of the acid remaining is given by this equation. Mole acid minus the mole of added titrant or the base added. Okay. So wala na tayong problem with the baba. No? Alam na natin paano ma-solve. How about the numerator? Gaano kadami yung aking conjugate base? Depende sa dami ng titrant na nilagay ko. Remember that when I add titrant, dun lumalabas yung conjugate base, di ba? Okay, so that means the moles of the titrant I added in the Erlenmeyer flask, no? Yung dami ng moles ng base na dinagdag ko sa Erlenmeyer flask, that corresponds to the moles of the conjugate base. Okay? So that corresponds to the moles of the conjugate base, no? Okay? So that means this is empty VT. Okay? Kung gaano karaming titrant nilagay mo, ganun karami yung conjugate base mo. Okay? Okay, so sana gets, no? Okay, so that is how Henderson-Hasselbach equation will be used, no? Dito sa problem na ito. Okay, so pKa, negative log ng Ka. Ka is given. If not given, tumingin sa table sa chapter 4. No? May table akong provide sa chapter 4. Andun yung mga Ka values. Yan, plug in mo dyan. Then you have the log of the concentration of the conjugate base divided by the acid. No? Again, conjugate base, galing yan sa titrant. No? Na-produce yan nung nagdagdag ka ng titrant, no? To be specific. Okay? Hindi siya technically galing sa taas. No? Na-produce siya because you added titrant. Okay? Let me clarify myself. No? Okay. So, yan. So, since we added titrant, the amount of conjugate base added is nagko-correspond siya with the amount of the titrant added. No? So, yan. Kaya yun yung equation natin. For the moles of this, ito naman, this is the moles of acid remaining. So basically, pag subtract mo lang gano'ng karaming acid minus gano'ng karaming titrant dinagdag mo. Okay? So that's the equation that we will use. Then, dagdag ka pa ng titrant. Dagdag. What will happen? You will reach now the equivalence point now. Equivalence point is the point wherein the moles of analyte is equal to the moles of titrant. Okay? Ibig sabihin, equal na silang dalawa. Okay? So, yun. Ngayon, what will happen sa solution? If the reaction is complete, we can write the equation as this. Now, HA is your weak acid. Sodium hydroxide is your strong base. You have NaA plus H2O. At equivalence point, what is the condition? Lahat ng reactant naging product na. Equivalence na. Okay. Lahat sila na-convert na into product. That means wala na tayo neto. Wala na tayong acid. Ang natira na lang ay conjugate base and tubig. Okay? So, ibig sabihin, wala nang buffer system. Sira na yung buffer. Kasi wala na sila eh. Conjugate base na lang and tubig na tira. So, that's why nilagay ko dito, the species present is itong dalawa na lang. Okay? Ngayon, of the two species, which of them will contribute to the pH of the solution? Any idea? Kasi 'di ba sa strong acid, strong base, water and salt natira sa atin. So sino nagko-contribute ng pH doon? Yung water lang kasi yung salt floating around lang. How about in this case now? Of the two species present, which of them will contribute to the pH of the solution? Any idea? Dalawa lang choices nyo. Water, conjugate base. Ano sagot? Pwede nyo i-type sa chat box natin sagot nyo. Okay lang manghula. Kasi syempre hindi nyo pa siguro alam, no? Kaya okay lang. Any idea? Conjugate base po, sabi ni Levin. Si Halyusin, ganun din. Okay? So, si Lian, ganun din. No? So, ang sagot ay conjugate base. No? Yes, tama kayo dun. Because the strength of the conjugate base, no, mas mataas yun relative to water. Okay? Mas mataas yun relative to the water. Okay? Mas matapang ang conjugate base kaysa sa water. Tsaka yung word na mismo, no, base, no, ibig sabihin, basic solution to. And that means at equivalence point, no, ng Wasb titration, ang pH ng equivalence point ay basic. Why? Because the conjugate base contributes to the pH of the solution at equivalence point. Okay? So kung sa strong acid, strong base, ang pH at equivalence ay 7, kapag weak acid, strong base, ang pH at equivalence ay ano? Greater than 7, less than 7, equal pa rin sa 7. Hula kayo. Anong sagot? What is the pH of the solution of the Wasb titration at equivalence point? So the pH, sabi ni Emmanuel, is greater than 7, which is correct. Okay, so sabi din ni Alyusin. Okay, nagigets ba? Bakit ganun? Okay, bakit greater than 7? Kasi nga base, no? And remember, kapag base, pH is greater than 7. Okay? So, kapag nakakita kayo ng Wasb titration, wag nyo isasagot 7 dito. SASB lang yun pwede or SBSA. Pero kapag dito, isosolve mo talaga. Okay? Na wala kang kawala sa solving. Kaya nga may nakalagay dito eh. Okay, if you look at the equation on the right side, obvious na basic yung pH mo dito kasi OH yung nilagay ko dun eh, 'di ba? 'Di ba? Okay? So yeah. And let's explain why this equation is written this way. Na bakit ganyan yung way to solve for the pH at equivalence point? Okay. Remember, at equivalence point, we do not have any of this. We only have the base, the conjugate base, and the water. And what will happen? The conjugate base can actually react with water. Okay? Zoom in tayo dito para medyo malaki. Ayan. So, the conjugate base, NaA, will react with water. And that is in equilibrium. Ano magagawa natin dito? Tanggalin ko na yung sodium. Spectator ion lang naman yung sodium. Okay? Ano meaning ng spectator? Ibig sabihin, nakikinig lang sa sa chismis ng reaction. Nakatingin lang sila sa reaction. Okay, so that means those are ions not involved in the chemical reaction. So what happens is that your conjugate base will react with the water to produce HA and OH. No? Sino mas malakas dyan? Di malamang OH. No? Okay, OH yan. Okay. And this reaction is described by the KB, the the base dissociation constant. Okay? Kapag acid dissociation constant HA, H plus yung nasa product side. Pero kapag KB, base dissociation constant, ang nasa product side ay OH. So that means basic solution ito. Okay. So let's write the KB expression for this equation. KB equals concentration HA, OH minus divided by A minus. Yung tubig hindi nilalagay. Bakit? Constant ang concentration ng water. That's always 55.56 molar. Pangalawa, the activity coefficient of water is the activity of water is unity. No? For solids and liquids, the activity is 1. No? Okay, so ibig sabihin, hindi na sila magpe-play ng role sa equilibrium constant kasi 1 la sila. Okay? So, ayan. If you use ice table, syempre maglalagay tayo ng x. So the numerator can be written as x squared and then this one is Ca minus x. Small x approximation tayo, burahin mo yung x. assuming that the ratio is greater than 1000. You know that already. So we can write this as x equals square root of the concentration of the conjugate base times the Kb. That's why the equation below is written that way. Ca minus Kb square root. Nasundan? Saan galing to? Hindi ko yan kinuha sa hangin. No? Hindi to quantum mechanics na out of nowhere yung solution. Ito ay galing sa equilibrium. Okay? So, yan. May explanation. Alam nyo na kung bakit. Siguro kung tatanungin ko kayo, kung nag-face-to-face classes na tayo, tapos nakita nyo ako, pwede tanungin ko kayo neto. Kailan? Alam nyo sagot, ha? Okay. So, this is the reason why we have this equation. Okay? And of course, to get the pH, edi ano lang, gawin mo tong POH, then i-minus mo sa 14. Okay? Subtract mo sa 14. Ito yung problem. I know the equation. Walang problema doon. And ano yung problem? Ano yung concentration at ano yung Kb? Okay. So, Kb muna tayo. Madali lang kasi yung Kb. Paano kinukuha yung Kb? From Ka. You know, Ka, Kb equals Kw. What is Kw? 1 times 10 raised to negative 14 at 25 degrees Celsius. So, for you to solve Kb, you just divide Kw by Ka. Tapos, ang problema, how about A? Okay? How about this one? The concentration of the conjugate acid. I mean the conjugate base. Saan galing yung conjugate base? Sa ano, yung analyte mo, lahat sila na convert into product, 'di ba? Okay? Remember the equation kanina, HA plus NaO, lahat 'yan magiging conjugate acid. So lahat ng analyte mo naging conjugate base na. Kaya ganito yung equation natin. Okay, MAVA yan or VAMA. Okay, so mole of the analyte divided by the total volume. Siguro you may ask, sir, kanina dito MTBT. But dito ngayon MABA? Remember, equivalence point to. So ibig sabihin, this is equal to MTBT as well. Okay? So the MAVA is equal to MTBT then. So pwede mo ipalit to. Kung ayaw mo ng MAVA, lagay mo yung MTBT. Okay lang. Kasi equivalence point tayo. Okay? So equal kasi silang dalawa. So you can interchange the two. But again, it is preferred that you use the analyte. Why? Kasi lahat ng analyte na-convert na into the conjugate base kasi. Yun yung knowledge natin dito sa equivalence point. Lahat na analyte na convert na into that. Okay? So, we use MAVA or the VAMA. So, again, pwede mo pa rin gamitin tong MTVT. Though, we prefer to use this, no? Kasi we follow the stoich. According to stoich equation, lahat ng ito napunta doon. Okay? So, yan. Gets na. Bakit naging ganyan? Hopefully, gets na. Pag hindi, tanungin. Okay. So, yun na yung explanation nun. Then, after nun, dagdag ka pa titrant, lagpas ka na sa equivalence point. Yan ay kulay violet na. Okay. Lagpas ka na sa endpoint. Purple na yan, violet na. Lalabas na si Barney dyan. Okay. So, when you are at the post-equivalence point, the species present in your solution are water, conjugate base, and the excess strong base. Of the three species present, sino ang magko-contribute sa pH ng solution? E di kung sino yung mas malakas. Sino mas malakas? Yung conjugate base or yung strong base? E di malamang yung strong base. Okay? Strong base yung magko-contribute sa pH ng solution. That's why, in the post-equivalence point, we can use the same formula as the strong acid, strong base titration pag post-equivalence. That is MTVT minus MAVA divided by V total. You can also see here that this equation is equal to this. VT minus VTEP times MT divided by V total. Remember, VTEP, ito yung ating friend. siya si volume of titrant at equivalence point. Same tong dalawang equation na to. Same sila. Bakit? Ano ba yung purpose natin? Why we use this? We are getting the excess titrant, the concentration or the moles of the excess titrant. Excess minus yung yung nilagay mo minus yung nagamit equals excess, di ba? So excess titrant tong equation na to. Alternatively, you can compute for the amount of the excess titrant using this, no? Remember yung VT, VTEP, si VTEP natin. Ito yung amount ng titrant to neutralize all the acids. O, ibig sabihin nun, yung sumobra na VT, isubtract mo na lang sa VTEP para malaman mo ilang ml sobra yung titrant mo. Then yung ml na sobra ng titrant mo, i-multiply mo na lang sa molarity. You will get the moles of excess titrant. No? So again, this equation is the simplification of this one. Can I also use this sa SASB? Yes. Pwede rin po ba ito sa SBSA? Yes. No? Pero ang reason bakit ito yung pinagamit ko last time is para alam nyo bakit. No? Ngayon, may additional shortcut tayo. Again, bakit ganito to? Because we are solving for the excess titrant. No? So there are two ways to do that. Ipag-subtract mo yung dalawang moles o kaya pag-subtract mo yung volume at equivalence point and yung dinagdag mo. And with this equation, you can get how much gaano ka-excess ang base mo. And you can get the pH at the post-equivalence point. Gets ba natin? Hindi na siya blurry ha. So ibig sabihin yan, pag nakita nyo tong equations na yan, alam nyo na saan sila nanggaling. Hindi sila out of nowhere. No? Hindi ko siya hinulaan yan. Hindi ko hinulaan yan. Okay? So may basis tayo dyan. Okay. If you watch other YouTube videos such as Khan Academy, Leia Forsai, Crash Course, Organic Chemistry Tutor, Professor Dave Explain, nanonood din kasi ako nun. No? Nagtuturo na ako pero nanonood din ako nun. Siyempre, kailangan ko rin ma-refresh. No? Kaya ako gumawa ng YouTube channel ko para kapag may nakalimutan ako, papanoorin ko na lang din yung sarili ko. No? Okay. So, ganun. Okay, so mapapansin nyo, dun sa mga ibang YouTube channels, they will provide different equation similar to your textbook. Pero yung equation ko, wala to sa textbook. Baka isipin nyo, ala, gawa-gawa lang yan, sir. No, ang basis natin dito is the small x approximation. We always assume we can use the small x approximation. That's why we use these equations. Yung nasa textbook nyo kasi, even si Klein, ako gumagamit ako ng Klein talaga. Kayo, Scoob kayo di ba? Yun yung required textbook sa inyo. Doon sa mga textbook na yun, equilibrium approach nila. Pero ako, shortcut. Bakit? Magsawa ka pa mag-quadratic equation. Pwede naman mag-shortcut, di ba? Okay? And saka multiple choice naman yung sagot. No? Although may difference yung shortcut pati yung sa actual equilibrium, multiple choice ang exam. Remember that. No? Ibig sabihin, malapit yung makukuha mo sagot sa choices. Okay? Nagamit ko nga ito ng board exam. Pumasa naman ako. Mataas naman score ko sa Anachem nun. So, ibig sabihin, pwede natin gamitin to. Okay? So, yan. So, yan ha. So, use this equation para mas mapadali ang buhay. So, again, hindi pwede yung nagkakabisado lang tayo. Hindi pwede, ganito yung equation dyan. No. College tayo and may licensure exam tayo. Although hindi kayo chemist, yes, I know. Pero, it will still be best, no, if you know why the equation is this, no. Nag-aano na tayo, nasa higher level na tayo ng Bloom's taxonomy kapag alam nyo kung bakit ganito to. Sa ibang teacher siguro, no, I don't know kung sino mga teacher yon, sasabihin, ito yung equation na gagamitin nyo dyan, solved na. Pero papansin nyo ako, didiscuss ko pa bakit naging ganun, no? Okay? So, kasi we are approaching, no, we are trying to hit the highest level sa Bloom's taxonomy, which is evaluation and analysis, no. So, hopefully, nakikita nyo yung importance na. Kasi kahit makalimutan mo to, basta alam mo kung ano yung meron kang species, kaya mo isulat ulit to. Okay? So, ganun ako. Hindi ko kabisado to actually. Wala, sa Anachem, hindi ko masyado kinakabisado yung mga ganitong equation. Bakit? Kasi ang basis lang naman ito is equilibrium. Pwede ko i-derive uli yan. Okay? So, pwede ko na yan uli i-derive as long as I know the foundation topic. Okay? So, ganun. Hopefully, ganun din kayo, no? Kasi kami nung BS Chem, wala kaming index card. And masama loob ko dun eh. Wala kaming index card, kaya lahat ng shortcut na gawin mo. Ako, ginagawa ko, I understand the basics. So that, pag nakalimutan ko yung shortcut, I know the basics. Pwede ko kunin uli. No? Ganun ginagawa ko. Okay. Yan. So, sana ma-adapt nyo yung ganun style ng learning. Kasi again, ang bahay, kapag pangit yung foundation, masisira. Okay? So, yan. So, sana maganda foundation natin sa equilibrium. Okay? So, now, let's proceed. This is how the titration curve for the monoprotic acid-base titration of WASB will look like. Ganyan yung itsura niya. As you can see, mababa yung pH initially, of course, acid yun eh. And then it will slowly increase, and then we will have this region wherein the pH seems to be stagnant. No? The pH where it seems to be stagnant, we call that the buffer region. No? Nagagawa na naman ng baby yung mga pusa. Okay, wait lang ha. So, ito kasi may baby cat ako eh. Ayan. Anyway, so ayun. Okay, so again, in this region, you have a buffer system, no? You have a buffer system, kaya slow yung increase ng pH. And then after that, once the buffer is destroyed, you will have the inflection point. And again, on the inflection point, andun yung equivalence point. Take note that ang ating conjugate base ang nag-exist dito. That's why the pH is higher for this one. Then after that, post-equivalence point. Okay? Baka isipin nyo, baka gawa-gawa lang yan ni sir. No. Hindi. Ayan, dito sa Excel, example. Ito, experimental data to. Ayan, kapansin nyo. Tataas, then suddenly mag-stagnate. Okay, dahan-dahan na siya aakit. So this is the buffer. And after that, stonks na. Biglang aakyat. So you have the inflection point here and then the post-equivalence point. Hindi joke time yung sinasabi ko na dahan-dahan ang maakyat kasi ito dahan-dahan. Yan. Okay? So yan. Okay, so with all those idea, let's apply them in this problem. Onti lang yung items na sasagutan ko this time na. Kasi I want you to practice more. No? Pero yung step by step, anuhin ko talaga. Kakarerin natin to. Okay. Generate a curve for the titration of 50 ml of 0.1 molar acetic acid. The Ka is given with 0.1 molar sodium hydroxide at 25 degrees Celsius. Okay. So, ano una kong gagawin? Kunwari, wala tong label na to. Isipin nyo, nasa canvas yan, tapos may oras na tumatakbo sa gilid. Ano una nyong gagawin? Magpapanik? Hindi. No? Okay, magpanik. Basahin nyo uli yung problem. Generate a titration curve of this acetic acid. So, sabi ko, kung sino yung unang sinabi, siya yung analyte. Followed by that is the titrant. No? Ngayon, alam mo, may analyte, may titrant. Pero, remember, apat yung condition natin. SASB, SBSA, WASB, and WBSA. Alin dun sa apat? Kasi, magkamali ka ng equation, mali sagot mo sa lahat. Okay? So, ano gagamitin mo dun? Identify mo what is the type of your acid. Acetic acid. And we know acetic acid is a weak acid. So, ibig sabihin yan, WA Then yung titrant mo ay sodium hydroxide. You know, this is strong base, SB. WASB. Ayan yung gusto ko ma-develop sa inyo sa ano ha. Hindi ko sasabihin kung anong type ng hindi ko sasabihin kung anong type ng titration 'yan. Ang gusto ko is alamin nyo kung ano yung type ng titration na 'yan. Okay. Baka kasi i-expect nyo sa Canvas pag nag-quiz kayo. Number 1, WASB. That's yung problem. No. Nakalagay lang doon words, no? Sentence agad. Okay, na bahala magsagot. Okay? Hopefully clear tayo doon. Sige, let's continue. Ano gagawin ko? Alam ko na, this is WASB. I know the corresponding equation. Susunod, hanapin si VTEP. Okay. The volume of titrant at equivalence point. How? If you could still recall last time, we assume that at equivalence point, the mole of titrant is equal to the mole of analyte. We express the moles in terms of molarity and volume. Titrant pala yan. That's MT VTEP equals MAVA. So VTEP is MAVA over MT. Plug in 50 times 0.1 divided by 0.1, cancel 0.1, same lang naman. So VTEP is 50 ml. Okay, gets na yan. Gets na yan dapat. Alam niyo na mag-solve ng VTEP. So again, first step, identify the acids and the bases. So you will know what type of titration you are doing. Second is to identify VTEP. After nun, assign the stages. Pag less than 50, pre-equivalence point. Pag 0, malamang initial. Then pag lagpas sa 50, post-equivalence point. Yan. Yung mga yung mga alam na yung gagawin, malamang nasa next slide na kasi yung sagot. Yung mga alam na gagawin, pwede magtuloy-tuloy na kayo. Pero again, explain ko pa isa-isa. Okay? So, yan. So, I know that this is WASB titration. So, I have the corresponding equations to be used in the previous slide. Nagsasolve na ako. Initial. Again, initially, we can solve for the pH as hanapin mo muna yung concentration ng H+. No? So that's the square root of Chaka. Okay. Let's plug the values in this equation. Concentration of acid 0.1 times the Ka, 1.8 times 10 raised to negative 5. Okay, negative log mo yan, you will get the pH. Doon ko na magagamit yung calcu ko. Okay. pH, negative log square root ng 0.1 times 1.8 times 10 raised to negative 5. Ayan, 2.87. Diba? Sana na-appreciate nyo to. No? Kasi diba dati, ganun lang ako. Ngayon, alam niya na pinipindot ko sa calcu. Okay, para hindi na rin kayo magkamali. No? Sir, ba't mo ni-negative log yan? pH kasi kailangan. Okay. I-plug in muna yung plug in muna yung concentration ng H+ dito sa negative log. Okay. And let the calculator do its work. Ayan. 2.87. Okay. So we're good, no? Okay. So if you have any problems, just let me know. Now we are on the pre-equivalence point. Pre-equivalence point, that means we have buffer system right now. Okay, we have a mixture of the conjugate base and the acid. No? So that means we have to use the Henderson Hasselbach equation, which has a form pH equals pKa plus log ng conjugate base. Conjugate base over the concentration of the acid. And you know that the concentration of the conjugate base is MTVT, okay? And the concentration of HA is MAVA minus MTVT. Okay? Na-explain ko na yan. Bakit na kanina? Ayan. Masyado ako maputi eh. Ayan. So, yan. You know why? Bakit ganyan yung equation na? So, hindi ko na ulitin. Plug in na lang yung numbers, no? So magko-color ako dito. So if you have colored pencils or colored ball pens or highlighters, it will be better para hindi kayo malito kung ano yung number na yon. I-highlight niyo yung titrant, i-highlight niyo yung analyte, no? To help you no sa pag-solve para hindi kayo ma-confuse. Okay? So, yan. pKa pala muna. No? So, how do you get pKa? Negative log yon ng Ka. So, negative log natin. Negative log 1.8 times 10 raised to negative 5. 4.74. Okay. 4.74 down. Okay, so let me write pH 4.74 plus logarithm. Zoom in ko ha. Ano nasa taas? MTBT. Black yung MT ko. No? So, 0.1 molar times 10 ml. Okay, nasa baba ko ay MAVA minus MTBT. Molarity analyte, volume analyte. So, that's given as 0.1 times 50 minus yun nasa numerator. Okay. Yan. So, i-highlight nyo kasi alam ko na confuse yung numbers, di ba? Para di kayo ma-confuse, highlight nyo. Okay? You may start plugging it in your calculator. Right lang. Ang kukulit ng mga mingming eh. Makukulit sila ngayon. Plug in nyo yan sa Calcia, may minimize ko, lalagay ko na dito. So that's 4.74 plus logarithm fraction 0.1 times 10 nasa baba, open parenthesis, mali. And parenthesis 0.1 times 50 close minus open 0.1 times 10 close, enter. Sagot is 4.14. 4.14. Nakuha? Okay. Siyempre, makukuha nyo yan. Nasa next slide sagot eh. Okay. So, yan. So, we have 4.14 there. Okay, nasa baba. Tuloy natin. 25 ml yan. So, basically, palitan lang natin yung volume ng titrant. No? Yung 10 gagawin 25. Kopyahin lang. pH 0.1 times 25. 0.1 times 50 minus 0.1 times 25. By the way, kapag naggaganito kayong calculation, kunwari, tuloy-tuloy lang yung add ng titrant, tapos nasa pre-equivalence point kayo, huwag nyo burahin to. Huwag nyo na burahin. Papalitan nyo lang yung volume. Okay? Kasi binubura nyo pa yun, sayang yung time. Plug in nyo na lang yung bagong volume. Analyte yan, huwag mo babaguhin yan. Yung titrant yung babaguhin. 4.74. Let's stop here. 4.74. Do you notice something? May nanonotice ba kayo? Sige. So, comment nyo kung ano yung nanonotice nyo. Siyempre, wag nyo i-comment yung ang hirap po. No? Given na yon. Ano yung nanonotice nyo at 25 ml? Kung meron kayo nanonotice, sige. I'll give you time. Wala kayong napapansin? Tingin uli kayo sa equation and sasagot natin. Same value po sa pKa. Vol lang po ng titrant nagbabago. Okay? So, pwede rin yan. Pero ang significant dito is yung same yung value ng pKa. Okay? Ito, tatanungin na naman natin sarili natin, why? No? Ganun talaga sa chem. Lahat ng pwede tanungin na why, itanong nyo. Malay nyo, mapalitan nyo sina Albert Einstein, di ba? Okay. Sina Niels Bohr, no? Kasi ganun yung ginagawa ng mga Nobel winners, no? Okay, pag naaral nyo yung quantum mechanics, kasi yun yung subject ko ngayon sa grad school. ang tanong lang nila is puro why. Okay, so sana tayo din ma-develop natin yung why question. Tignan mo, 474. 474. Why? What do you think happened? The value of the log function is 0. Bakit? No? Kasi ganito nangyari. What is 0.1 times 25? So that will be 2.5 millimoles. What's 0.1 times 50? 5 millimoles. Minus 0.1 times 25? 2.5 millimoles then. Basically, you have 2.5 millimoles on the numerator, 2.5 millimoles on the denominator. According to math, equal yan sa 1. And the logarithm of 1 is 0. Ano ngayon? Ano naman ngayon? Ganito. Tignan nyo rin yung volume. Tignan nyo yung volume. Okay. Ano mapapansin nyo sa volume? This volume is half the endpoint volume. Ibig sabihin, at V equals half ng VTEP, okay? At volume na kalahati ng VTEP, the pH is equal to the pKa. pH is equal to the pKa when the volume of your titrant is halfway sa endpoint. Halfway sa endpoint. Okay? So, ano ulit yung mga takeaway natin dito? Una is that if ang volume ng titrant is halfway na siya sa endpoint, then ang pH ng solution is the pKa itself. Okay? So, the pH is the pKa itself. Pag halfway ka na, 25 na to kalahati na yun ng 50. Diba? Bakit nagiging ganun? Kasi, if you are halfway in the process, yung analyte and titrant mo, nagmi-meet din sila halfway. Kunwari, ito yung analyte. Ito yung titrant. Pag nagdagdag ako ng titrant, mababawasan yung analyte. What will happen? They will reach a point wherein equal sila. Okay? Slowly magiging equal sila. Ito yon. Dito yon sa fraction na yon. So slowly they will become equal. And once they are equal, then we are halfway. Pag ganun na tayo, patapos na tayo, then ubos na. Ubos na yung analyte. Okay? Tapos na yung reaction. Equivalence point na yan. Na-imagine nyo yun? Kung hindi, isa pa. Ito, analyte. Ito yung titrant. Pag nagdagdag ka ng titrant, aakyat to, yung analyte mababawasan until to a point na equal na sila. If they are equal, then we are halfway to the end of the reaction. That means, yung pH, itong fraction na to, magka-cancel out yan. As a result, magiging 0 tong log function and the pH is equal to the pKa. Amazing, di ba? Amazing. Okay? Ayan. Hindi ko alam kung na-amaze talaga kayo. Pero for us na nakakatuwa yung ganung bagay. No? Logical, no? Kasi nag-i-equal sila na 50% ka na bago matapos. Di ba? Hindi mo to makikita sa strong acid, strong base. No? Walang ganun sa strong acid, strong base. Only sa buffer systems. Diba? Amazing. Okay. Ayan. Yan na. Take note of that. Kasi, malay mo, lumabas sa quiz. Dalawa yung quiz natin, ha? Okay? Dalawa yung quiz natin. Kaya, lalabas at lalabas yan. Kung di man lumabas sa quiz yan, edi na sa final exam. Okay, so endpoint. Equivalence point, endpoint. Same lang halos yan. Okay. So we are now at the equivalence point. What equation to be, ano yung equation na gagamitin natin? OH equals the, sulit ko dito sa baba. Is equal to the square root of the concentration of the conjugate base times the KB. Okay. CBKB, conjugate base times KB. Okay. Ngayon, how do we compute for the concentration of the conjugate base? Sabi ko nga sa inyo, yung mole ng titrant equal na sa mole of analyte at equivalence point, no? Iba yung dito sa halfway, ha. Ito 50%, no. Pero at equivalence point equal na talaga lahat, no. They are all stoichiometrically equal. Okay? So nasusunod na natin dito yung yung balanced equation na. Okay? So, ayun. How do you compute for the concentration of the conjugate base? Pwedeng MTBT, pwedeng MAVA, but convention says na MAVA tayo. Kasi we know that all the analytes have been converted to the products na. Kaya MAVA gagawin natin. Parang stoic lang din. Okay? So, that's MAVA divided by V total. Bakit may V total sa baba? Dilution kasi. Okay. Dilution yung nangyari. Dumami na yung volume natin eh. How about the KB? Again, KA, KB equals KW. KB is then equal to KW divided by KA. Gets? Okay, sana nag-gets na. Ano na susunod? Edi plug in yung numbers. Plug in yung numbers, square root. Hindi ko alam yung approach ng ibang chem prof, no? Kasi feeling ko yung iba tapos na dito pero tayo, we are halfway. Pero, yun, lahat ng kabagalang gagawin ko para ma-explain natin lahat, no? Yung iba kasi dadaanan lang talaga eh. Okay. Pero ako ayoko ng ganun. Kasi bilang estudyante, ang dami ko rin tanong dati. Gusto ko masagot yung mga tanong. Okay. Hopefully, nadadaanan ko yung mga question in mind. Okay. So yan, plug in natin ito dito. We have the MABA. 0.5. May 0.5 ba yun? Sorry, 0.1. Typo pa. Okay. Zoom in. Ayan. We have 0.1 times 50 ml analyte over, ano yung total volume? 50 plus 50. 50 ml analyte, 50 ml titrant na. So 100 ml na tayo. We are halfway bago mapuno ang Erlenmeyer flask. Okay. I multiply that by KW over KA. 1 times 10 raised to negative 14 divided by KA, which is 1.8 times 10 raised to negative 5. Okay. Pa-plug in ko to sa calcu ko. OH yan. Gusto ko PH eh. Mag-shortcut ako bago ako magpindot sa calcu, shortcut. Kung napapansin nyo last meeting, isang pindot ko lang, may sagot agad ako. Bakit? Kasi ginagawa ko sa calcu is ganito. Since you are looking for pH, that's 14 minus POH. Ginagawa ko sa calcu, pinipindot ko ganito. 14 minus negative log square root ng something. Iniisa na. Pinagsasama-sama ko na para mabilis. Okay. So it's up to you. Kung gusto nyo yung stepwise, okay lang. But ako, I prefer this isang bagsakan. Para kapag mali, bagsak talaga. Isang bagsakan na. Pero kapag tama, at least tama yung sagot. No? Okay. Ayan, basta ganun ha. Be careful. Okay. So ito yung pa-plugging ko, 14 minus negative log square root of something. No? So ayan, 14 minus negative log. Again, magkaiba yung minus sa negative. Kung mapansin nyo, yung minus longer than the negative sign. Mag-ingat na kasi yung iba sa inyo, alam ko ginagawa, minus minus. No? Bad yun. Pwede rin naman gawin yung plus yan. Kasi negative times negative is positive. Pero again, ayoko gawin. So that's 0.1 times 50 divided by 50 plus 50 times fraction ulit. KW1 times 10 raised to negative 14. By the way, kapag exponential, ito pipindutin nyo yung x times 10 raised to x. Okay. Huwag nyo nagagawin yung 10 tas raised to ganun. Wag na. Okay. Sayang yung effort. 1.8 times 10 raised to negative 5. Yan yung sagot. 8.72. That's the pH of the solution. And is it consistent with our analogy earlier today that kapag weak acid, strong base titration, the pH at endpoint is greater than 7? Ang sagot nyo ay greater than 7. And yes, it is consistent with our prediction kanina. Prediction talaga. It is consistent with our analogy. Okay? So, consistent siya. Ibig sabihin, hindi ako nagjo-joke. Okay, so hindi ako nagjo-joke time. Ay, nawala. Daldal ko, nawala tuloy. Ayan, ayaman na. Basta malaga, consistent yung sagot natin. Okay, so yun. Gets. Gets. Sana gets, no? Ay, yun lang, naburo. Ano ba yan? Yan yun na, nasa next slide naman yung mga nakasulat. Kakainis. 1 point, ano yun? 1.8 times 10 raised to negative 5. Okay. Ngayon, post-equivalence point. We are now solving for the excess titrant. No? And the excess titrant can be calculated as VT minus VTEP times MT divided by V total. Very easy. Sabi nga sa TikTok, very human. Okay. Ito, very easy. Tapos bigla-bigla ang dami nangyayari. No? Parang ganun yung mga quiz ko rin. No? Sabihin ko, very easy. Tapos biglang bulaga. No? Ganun din sa TikTok din. No? Okay. So, ayan, volume titrant, 50.1. Ay, minus. Wait lang. Malabo yung sulat ko. Wait lang. The design is very human. Diba? Tapos mamaya hinahampas na yung mannequin. Okay. Very human din naman yung quizzes ko, di ba? So, VT, 50.1 minus VTEP, which is 50. Molarity ng titrant, 0.1. All divided by the total volume, which is 50 for analyte, 50.1 sa titrant. O, dito magkakamali. Baka kasi mamaya maisip nyo, ay, parehas lang to. No. No. Hindi. No. Ito, analyte and titrant yan. Ito yung sa titrant. Yung analyte yung sinabi kanina. Okay? Okay, so yan. Plug in natin yan. Let's get the pH. No? Ano yun? 14 minus negative log. Bakit ako nag-14 minus something? Kasi POH makukuha ko dito eh. Kung gusto ko pH, edi 14 minus the POH na. Okay? Sana na nakikita niyo yung mga ganung bagay. Na. Mabilis ako matapos mag-solve na. Okay, shortcut. Nakakatamad kasi eh. Yan yung sagot natin. 9.999 or 10. 10.0. Okay. Round off nyo na yan. Okay. Again, pag POH yung nakukuha nyo, pwede lagyan nyo na sa harap ng 14 minus the negative log. Huwag lang kayo magkamali ng sign. Okay. So, yan. Para isang pindot lang tapos. No? Okay. So, ito yung answer natin. Yan. Okay, so these are our answers. Again, take note of what I said earlier, that halfway through the end of the titration, which is the end point, no, or the equivalence point, halfway through the titration, for weak acid strong base, the pH sa halfway na yon is equal to the pKa. As the concentration of the conjugate acid, the conjugate base and the acid is equal. Okay. So, true ba to sa WBSB SA titration, sa weak base strong acid titration? Yes, true din yan. True yun sa, basta may buffer. As long as halfway ka sa end ng titration, true itong ganap na to. No? Kapag 50% ka na sa titration, the pH is the pKa or the pKb. Pag base naman. Okay, so yan. Sana na-gets na. I will leave this item as your assignment. Assignment na lang to. Okay, so this is an assignment for you na lang. Okay. Yan, assignment na lang to for you. Okay, so I want you to practice, no? Practice nyo na yung use ng mga equation. Assignment na lang to ha. Bibigay ko na lang yung sagot sa worksheet. Lalagay ko sa worksheet yung answers. Okay tayo doon. Bakit ko ipapa-assignment yan? Kasi para ma-practice. Okay. Okay tayo. Okay. Next one, we have the weak base strong acid titration. So, sino na una? WB or weak base. No? So, that means we have a weak base titrated with a strong acid. Okay. So, that means may pa rin tayo, equilibrium system pa rin tayo. Okay, so this is the counterpart of the WASB. Okay, so WBSA is the counterpart of the WASB. Okay, sana nagigas nyo na yung mga abbreviation natin ha. Okay tayo dan. Dami nagme-message sa nag-my day kasi ako ng something, kaya ang daming message, nakaka-distract. Anyway, so yun, 4 na stages pa rin tayo. Let's define ano nangyari dito, bakit naging ganun yung equation. Let's start. Okay, initial, ibig sabihin nun, weak base lang yun nasa solution and the water. Of the two species, which one will contribute to the pH of the solution? Malamang ang base, kasi nga, base siya. Okay? But base natin dito is a weak base. No? Okay? So, if a weak base reacts with water, what will happen? It is in equilibrium. No? Mali yung arrow ko. If our base reacts with water, what will happen? We will produce BH plus and OH minus. May OH sa product, meaning KB. Okay? We are talking about the base dissociation constant kasi may OH sa product. Let's write the KB for this question. For this equation, that is KB equals BH plus OH minus divided by concentration of base. Yung H2O hindi mo ilalagay. Bakit? Hindi kasi pwede. Because of the activity is equal to 1 o kaya constant kasi yung concentration niya. Yun yung sagot na. Okay? Using ice table, we can rewrite this as KB equals X squared divided by the concentration of base minus X. Using small x approximation, we can delete this x term. So we will get x squared equals CB KB. Kunin mo square root. So you have the CB KB. Gets? Yun. Yan yung dahilan. Bakit ganyan yung equation? Ano lang, equilibrium lang. Okay? Di ba, papansin nyo, as long as you know the equilibrium, alam nyo kung paano i-derive yung sagot na. Okay, so yan. Now, at pre-equivalence point, we are now adding acid titrant. No? Nagdadagdag na tayo ng acid. What happens? Yung base na babawasan, yung conjugate acid na dadagdagan. Okay? So, yun na yung nangyayari sa atin. When we add titrants, what happens is that base, let's say HCl. Ano na nangyari? We are producing BH+. Meron na tayong conjugate acid. You have a mixture of base and a conjugate acid. Therefore, you have a buffer system where we can use the Henderson-Hasselbach equation. And for bases, the Henderson-Hasselbach equation is given as this. POH, PKB, log conjugate acid over the base. Now, alam na natin to. Paano ko i-solve to? On a similar fashion, sa previous na sinagot natin, ganun din dito. Okay. The reason why the conjugate acid concentration increases is we add titrant. Okay. So that means the moles of the conjugate acid added is equal to the moles of the titrant, which is MTVT. So, ganun pa rin. MTBT, nagpalit lang tayo ng subscript. I mean, nagpalit lang tayo ng species. Pero same pa rin ang idea. How about the base, no? Sabi natin dito, the base is less. Nababawasan na yung base. Okay. So, that means I have to subtract something from something, no? Okay. So, ano yung susubtract ko? The mole of the base minus the mole of the titrant added, no? Mole of the base minus the mole of the acid, no? And in equation, that can be written as MAVA minus MTVT. Pinagsusubtract ko yung dalawang moles, so I will know how much base is remaining sa solution. Okay? Clear tayo dito. Ganun lang din yun sa kanina. Okay? PKB, negative log mo lang yung KB. Okay? So, yan. What else? Ayan, tapos na tayo sa pre-equivalence. At equivalence point, we are assuming that all the bases have been converted to the conjugate acid form. That's why our solution contains water and the conjugate acid. Okay. Of the two species, which will contribute to the pH of the final solution? The water or the conjugate acid? Comment kayo sa chat box natin. Of the two species, which of the two will contribute to the pH of the solution? Water or the conjugate acid? Comment kayo. Conjugate acid, conjugate acid, conjugate acid. The answer is conjugate acid. Okay. Obvious naman, na. Kasi counterpart nga lang to ng kanina. Kung kanina conjugate base, ngayon conjugate acid. I will ask you this, na. What is the pH of the equivalence point? 7, greater than 7, less than 7. Sige. Less than 7, less than 7, less than... Okay, less than 7. Bakit? Kasi nga, sabi natin, the conjugate acid is contributing to the pH of the solution. That means, the solution is acidic. Kasi nga, may conjugate acid tayo. Andun yung word na acid, diba? Ibig sabihin, the solution is acidic, therefore the pH is mababa. Okay? So, ganun, no? Yun. Well, we may ask ourselves, bakit naging ano? Bakit ganon? Bakit nga ba mababa yung pH? No? Why? Because what happens in equivalence point is that our conjugate acid, no, the BH plus, it reacts with water, so it is in equilibrium, no, to produce what? H3O and the base. No? We produce H3O. No? Nag-produce tayo ng acid. Okay. So, ibig sabihin, this equation is the Ka equation. Kabaliktaran to ng sa base kanina. Okay? Kabaliktaran to ng equation kanina. Napapansin nyo, baliktad, di ba? Kanina yung base andito, ngayon andun siya sa kabila. Ibig sabihin, kung KB yung paganon, andito yung base. Kung nasa right side yung base ngayon, Ka na to. Okay? So, reverse na yung ating equation. Hence, the constant is also reversed. No? So, from KB, magiging Ka na yan. Okay? So, using equilibrium, let's write the Ka. We know Ka is concentration of acid times the base divided by the conjugate acid. Yung author, di mo sasama. Ice table will tell you the numerator is x squared, the denominator is concentration BH plus minus x. Using small x approximation, burahin mo yan, then you know x is equal to the square root of CBH plus times the KB, which is our, hindi yung KB, Ka. Ay, nawala. Nawala pala yung screen. Ayan. So, ayan. So, ito. Saan ba siya nawala? I don't know. Pero ito. Using equilibrium, no? Using equilibrium, numerator, denominator, ito, numerator, denominator, ito, yung water, di mo sasama. Ice table will tell you that these are x values. So, x squared divided by CBH plus minus x. Using the small x approximation, we can deduce, no? Reduce pala, sorry. So, we can reduce this equation to this, no? The square root of CBH plus Ka. Okay. Ngayon, hindi lang siya basta equation. May dahilan. Bakit yan yung equation? Gets natin? Okay. Kasi sa ibang class, binibigay lang nila yung equation. Tayo, ina-explain natin bakit ganun yung equation. Okay? Okay, so yan na. Now, alam natin yung equation. The problem is, ano yung number sa loob, no? Okay. For the Ka, initially, we will be given Kb. Paano ko gagawin Ka yon? Gamitin ang Ka, Kb equals Kw. So, to get the Ka, that is Kw divided by Ka. Kb pala, sorry. Okay. So, Kw over Kb is equal to Ka. You know that already because that was discussed earlier and sa last chapter. How about the concentration of the conjugate acid? No? Sabi nga natin, the conjugate acid, yan ay dahil sa equal na yung analyte and titrant. So, actually, we can use MAVA o kaya MTBT. Okay lang kahit ito gamitin mo. However, the convention tells us that we use MAVA. Kasi ano ba yung, di ba sa analyte naman talaga manggagaling dapat yung conjugate acid, no? So, ganun. Kaya MAVA gagamitin natin. But again, you can interchange the two, okay? Since they are equal, bakit? Kasi nasa equivalence point tayo. Nasa equal point tayo okay? So, parehas yan equal. V total, ipag-add mo lang yung volume. Okay? So, you now know why the equation is written this way. And lastly, we have the post-equivalence point. This is a point wherein there is an excess acid na, the presence of the conjugate acid and the water. So, of the three species, ang mas malakas ay excess yung acid na. Ito yung sa kalam na natin. Ito yung mas malakas na. So, ibig sabihin yan, the pH of the solution is solely dependent on how much excess acid you have. And just like last time, ganun pa rin yung equation natin. You can use the Vt minus Btep times the molarity of titrant divided by the total volume. However, since this is acid, what we will get is the concentration of H+. Take note of that, no? Baka kasi mamaya hindi mo mapalitan yan, no? Okay. So, clear tayo sa mga nangyari. Hopefully, clear tayo. Pag may question, itanong ha. Don't hesitate to ask. Kasi again, ang daming equations. Okay? So, ang daming equations. So, good luck. No? Now, let's answer. Bago tayo mag-answer. Okay? So, this is the titration curve. Na-discuss ko na to last time. Although, mabilisan lang. Again, pababayan. On this region, you have the buffer region wherein you have wherein the base and the conjugate acid exist. Okay? And again, halfway sa endpoint, no? Halfway sa endpoint. O nara, ito yung VTEP, ito yung kalahati ng VTEP. Ang pH is equal to pKa. Take note of that. Okay? Then after nun, equivalence point. The equivalence point has an acidic pH. Okay? And then after that, the post-equivalence point. Okay? Na-discuss natin maigi kanina and hopefully clear yun sa lahat. Ha? Clear ba? Okay, sana yes yung sagot. Pag hindi, you just ask na. Let's try this. A 50 ml alico of 0.05 molar sodium cyanide. Kb is 1.61 times 10 raised to negative 5 is titrated with 0.1 molar HCl. What's the answer? Kunwari, wala to. Kasi sa exam, wala yan. Wala din to. Wala din tong table na to. Ito lang yung nakalagay doon. Okay. Tas yung volume. Kailangan masanay tayo sa ganun. Don't worry, may bibigay akong worksheet para mag-practice kayo. And with answers din yan. Nawala ako. Anyway, ayan, you have the problem. Ano gagawin nyo? Unang-una, hanapin si analyte, hanapin si titrant, and then identify anong type sila ng acid or base. Okay? Strong ba sila o weak? Yung naunang sabihin, yun yung analyte. NaCN, malamang binigay na yung Kb, ibig sabihin yan, weak base yan. Titrant mo is HCl, ibig sabihin yan, strong acid. So the equation to be used is yung mga equation na nasa WBSA. Okay? Kasi again, 16 equations meron tayo. SASB, SBSA, WASB, WBSA. Sa 16 equations na yon, reduce that into 4 na magagamit mo. Okay, so it is important for you to identify what type of acid you have. After nun, hanapin si VTEP. Okay. So si VTEP, ang shortcut ko, ganito, mental na lang. Paano yung shortcut ko mentally? Yung mga non-zero digits, yun yung i-multiply mo. Multiply, divide. Okay. Try natin. 5 times 5, 25 divided by 1, 25. So, ibig sabihin, yung may 25 dito, yun yung VTEP. Okay. Shortcut. Pero again, for you to be, para kayo mas sure, kayo, na lang, i-calculate nyo na lang, okay? So, i-calculate nyo na lang para mas sure, pero again, better kung kaya nyo na rin siya i-imagine sa isip na. 5 times 5 divided by 125. So, ibig sabihin, 25 ml yung sagot. So, I know this is the EP, okay? And the other stages can now be assigned, no? So we have the initial, the pre-EP, and the post-EP. But EB. Yeah. Bulaga lang na. Post-EP. Yeah. So yan, I know the stages now. I also know the corresponding equations. So, ito task natin. I want you to work on this. Magsasagot din ako. Susulat ko lahat ng equations na. Kayo, wag kayo tumingin sa next slide kasi andun yung sagot na. Try on your own to write the equation. Ako, isusulat ko rin lahat na. Okay. Okay, makinig na lang kayo. Okay lang din. Okay. So, for initial, ano equation natin? OH, no? So, that's OH equals square root CBKB. Okay. That's the square root of the concentration of the conjugate base times the KB, 1.61 times 10 raised to negative 5. Plug in sa calcu. 14 minus negative log square root 0.05 times 1.61 times 10 raised to negative 5. Sir, bakit ka may 14 dyan? Kasi again, OH to eh. OH kasi to. Ang gusto natin ay pH. No? So, pag ni-negative log mo lang to, POH yan. Unahan mo na ng 14. No? 14 minus the POH. No? So, I want you to develop this. No? Para hindi na kayo mag-round off, round off. No? Okay. Sa discussion natin, minsan nagra-round off ako for your for simplicity. No? Para masundan nyo yung step by step. Pero pag ako yung gumagawa lang talaga ng assignment, tinutuloy ko na sa calcu yun. Kaya minsan yung calcu ko, ang haba-haba ng equation. Pag nagkamali ako doon, GG talaga ako na iniisa-isa ko pa yan. Pero ang advantage nun is hindi ka na magra-round off kasi. Okay. So, yan. Answer is 1095. Okay. So, good tayo dyan. Meow-meow daw, sabi ng pusa ko. Hindi pa nga ako kumakain, mamaya ka na. Hindi pa ako kumakain, guys. Mamaya ka na, baby. Okay, so anyway, so let's proceed with the next one. We are at the pre-equivalence point. Ibig sabihin, buffer. Okay, so buffer tayo. So the equation for this one is the buffer equation. So let ko dito, POH equals PKB plus log. Conjugate acid is MTBT over the base, no? Which is MAVA minus MTVT. Okay tayo dyan. Okay. So, yan. Plug in. By the way, PKB. Hindi ko alam yung value ng PKB. Calcu natin. Yan. Sa likod lang siya. Ingay yung lady. Negative log 1.61. 10 raised to negative 5. So PKB is 4.79. Okay, so 479. Round off na natin. Okay lang yun. So POH equals 4.79 plus logarithm. Plug in nyo yung numbers. Colored gagawin ko ha. Para mas makita nyo yung para mas makita nyo ano yung titrant, ano alay. So kulay blue yung titrant. Ano ba concentration nun? Concentration ng titrant is 0.1. Okay. Zoom in ko lang. 0.1 times 10. 0.1 times 10. Kulit. Very naughty cat. No? Tapos, analyte 50 times 0.05. POH makukuha nyo dyan ha. Minus 14 pa yan. Okay? Plug in ko to sa calcu. Ilalagay ko na yung minus 14 sa unahan ha. Okay? So, wag na lang mali to. Okay. Pwede, ito na lang muna, then saka may minus 14. Pero ako, I prefer yung tuloy-tuloy eh. Okay. 14 minus quantity. Parenthesis. Ay, mali. 4.79 plus logarithm fraction 0.1 times 10 divided by, mali yung aking 50 times 0.05 minus, close parenthesis pala, minus 0.1 times 10, close parenthesis, enter. 9.80 at 9.39. Na nakuha yan. Sana nakuha. Ayan. So, 9.39 ang answer. Sana nakuha. Okay. Nakukuha nyo yan. Nasa next slide yung solution eh. Diba? So, let's try. And the next one. Di ko alam kung naririnig niyo yung mga pusa pati aso kasi sa bahay may dalawa kaming aso tapos 15 na pusa. Ganong karaming pusa. Okay. Tapos may baby pa, di ba? Kasama na sila sa bilang. Ganon kami ka mapagmahal sa pusa. Okay. Okay, so ano na ako? Equivalence point. So again, at equivalence point, ang present sa solution ay the conjugate acid and it reacts with water to produce the hydronium ion. So what we can get is the H+. So this is the equation. This is square root of C conjugate acid times the Ka. And we know earlier that the equation for for the concentration of the conjugate acid is MAVA over V total. Yan yung equation for the conjugate acid concentration. And for the Ka, that can be calculated from Kw divided by Kb. So we will plug this into this now. Plug in natin yung mga yan. Okay. Sundan yan. Okay. So, plug in. Kagaya nga na sinabi ko sa inyo last time, hindi ko alam kung sa inyo yun, no? Pag master nyo to, alam nyo, pwede na kayo mag-take ng Chemtech board exam. Chemtech. No? So, bukod sa RMT kayo, Chemtech pa kayo. So, ano ginagawa ng Chemtech? Sila yung mga licensed to perform in chemical laboratories as well. Okay. So, mas maraming opportunities kapag Chemtech din kayo. So, bukod sa medtech, license nyo, may isa pa kayong license na Chemtech. No? Okay. So, MA 50 times 0.05. Tama yun, di ba? 0.05. Yes. Divided by V total 50 plus, 25? Okay, 25. Times, and kung gusto nyo lang mag-Chemtech boards, pwede yan. Kasi marunong na kayo nito eh. Ganito lang naman daw yung lumalabas dun. Even biology students nakakapasa ng Chemtech, no? Biology students, mga food technology, nutrition and dietetics, no? May mga kakilala kami na chemical technicians din, pero iba yung course, no? Okay. So that is designed for non-chem majors. No? This is a chemistry boards. We have 5 subjects, 100 items yon. So, mas mahirap ata, mas marami ata yung sa inyo, no? Kasi mas marami kayong board subject eh. Okay. So, basta ganun. Pag Chemtech naman, 3 subjects, no? Organic, Gen Chem, and Anachem. Okay. Pag master mo yung tatlong yun, yan, papasa ka. Okay. May mga kilala kaming bio students na pasado na rin. Ayun. Share ko lang. Baka gusto nyo lang. Para mas marami kayong trabaho. Okay, so that's negative log square root of 50 times 0.05 divided by 50 plus 25. Then multiply natin yan sa 1 times 10 raised to negative 14 divided by 0.61 times 10 negative 5. This is the pH, and we just proved yung inyong idea kanina that for weak bases, the pH at endpoint is acidic. Why? Because of the presence of the conjugate acid. O, diba? Galing, no? Kung kaya nyo ma-predict yun, ibig sabihin, pwede na talaga kayo. So, yan. Post-endpoint, post-equivalence point. Excess acid na lang to. Nga pala, acid yung titrant natin. So, let me zoom in. Okay, so that's H plus equals Vt minus Vtep times the concentration of the acid divided by the total volume, volume analyte, volume titrant. Sundan kung paano lumabas yung equation na yan. Vt minus Vtep times molarity titrant. Yun yung excess mole ng titrant divided by the total volume of the solution, which is 50 ml analyte, 26 ml titrant. Saan galing 26? Ito o, nasa gilid. Sasabihin naman yun eh. Okay, so let's calculate the pH. Balik ulit tayo sa calcu. Negative log fraction. Yan. 6 minus 25 close times 0.1 divided by 50 plus 26, enter 2.88. Okay. Sundan. Okay. Sana clear. Okay. Nakuha yon. Siyempre, makukuha niyan kasi yung solution ay nasa next slide. Ayun. At least ngayon alam nyo na. Ano to? Ano yan? Ano yan? No? Isang galing yan sa mga pinagsasabi ko kanina dito. Okay? So, yan. And hopefully, nakita natin yung relationship ng equilibrium topic dito sa main topic natin sa titration. Okay? Sana nakikita nyo yung relationships. No? And again, huwag kalimutan yung mga special ideas na binigay ko sa inyo. Huwag nyo kakalimutan yan. Okay? Kasi lalabas yun sa quiz or sa exam. At tas pag nag-face-to-face tayo, tatanungin ko kayo niyan. No? Okay. So this will be left for you as an assignment. Ay, sorry. Okay. So assignment nyo na lang ito. Okay. So you try, no? Identify the stages, no? Tulungan ko kayo. Asan yung VTEP? Sabi ko yung numbers lang tinitignan ko. 3 times 1 divided by 1, edi 3. Ibig sabihin may 3 doon. Either 3, 30, 300. No? So, sagot doon 30 ml. Ito yung VTEP. Okay. Then, you can assign the stages for others. No? Kaya na bahala mag-assign and write the correct equation to get the pH. No? Yan. Kahit di nyo na i-graph, okay na yun. Okay. So, we're done with the monoprotic titration. Okay. Makakahinga na tayo ng maluwag. Medyo pa lang. Okay. So, let's talk about indicators again. Last time, we defined indicators as chemicals, no? Specifically organic chemicals, no? That changes color when subjected to different pH, no? Siguro magtataka kayo, bakit kaya, no? Okay. So the answer there is quantum mechanics, no? Ito yung mga dinevelop na Niels Bohr, Schrödinger, no? Bakit? No? Kasi whenever yung ating electrons ay disrupted, no? If you assume a system is in a particle in a box. So meaning lang nun, kapag yung electrons nagagalaw, may corresponding energy doon. And the energy can be calculated to the wavelength, no? And yung wavelength na yon that corresponds to a certain color. Basically, pag ginalaw mo yung electron ng isang molecule, may corresponding color na makikita ka. Okay. So, yun yung reason bakit ang daming colors sa paligid. Okay. So, yun ang ating explanation bakit sila nagkakakulay. Anyway, so madidiscuss natin yan uli sa last topic natin, yung spectrophotometry. Mag-uusap tayo about colors doon. Anyway, so sa ngayon, what we know is that yung ating indicators, they show color at different pH, no? Okay, so ito yung ibang common indicators and here are some more, okay? You may ask yourselves, no, ang daming indicator, ano gagamitin ko, sir? No? Anong gagamitin ko? Okay, so ito yung idea sa chem. The indicator needed in an experiment or in a titration setup, no? Ang indicator na kailangan mo gamitin ay dapat matatamaan ang inflection point. Okay. Take note na yung inflection point may ano yun, 'di ba? Mahaba yung pH range nun, 'di ba? Kung gusto nyo makita, itong example ko, yung in-upload kong Excel. So, ayan, ito yung inflection point. Ano yung pH range niyan? From 6 to 11. So, ilan yun? Almost 5 yung pH gap. No? So, kailangan yung indicator na gamitin mo tatama dito sa length ng inflection point. Because again, at inflection point, tapos yung reaction. And for you to observe that tapos na yung reaction, gamit kang indicator that will change color within this region. Okay? So, yun yung idea. Gagamit ng indicator na magko-color sa gap na to. Okay? Paano ko, sir, malalaman, no? Okay, ganito. Good for us is that, ang good thing sa atin is that may mga common indicators na tayong ginagamit talaga. No? For example, phenolphthalein. This is used for SASB titration and WASB titration. Yan. Okay, so yun yung mga ginagamit for strong acid, strong base, strong base, strong acid, and WASB titration. Phenolphthalein talaga. Why? Kasi the inflection point, no, tumatama siya sa pH 8 to 10. Tumatama yan doon sa pH na yan. As a result, doon yun magbabago ng kulay. Okay. So, hindi mo pwede gamitin ito. Hindi mo pwede gamitin yung bromocresol green. Kasi the inflection point is around pH 10 to pH 6, no, for those type of titration. Okay. So, weak acid, strong base. Diba yung na-solve natin kanina na pH at equivalence point is 8.56, diba? 8.56 ba? Hindi ko maalala kung tama yung number. Basta 8 something. So, yung 8 something, pasok yun sa phenolphthalein. Okay? So, ibig sabihin, you will use phenolphthalein indicator for this type of titration. Ngayon, what if naman sa paano po yung weak base? Weak base strong acid, no? Ano na compute natin kaninang pH? 5 point something, no? So that means hindi gagana phenolphthalein doon. Kasi 5 point something yung endpoint mo. For you to observe that, you have to use an indicator that changes color within those pH range. Ano pwede mo gamitin? You can use the bromothymol blue or the bromocresol blue. Pwede rin yung methyl orange. So, itong tatlo, pwede mo gamitin. Pero again, isa lang. Kasi pag pinaghalo-halo mo yan, rainbow lalabas. Hindi, joke lang yung rainbow. Okay. Magugulo na yung colors. No? So, isa lang gagamitin mo dyan. I can use methyl orange, pwedeng BCG, pwedeng BTB, bromothymol blue. Okay? So, yun. Basta pasok ang pH ng endpoint dito. Ayun, pwede. Okay. So, yun ha. Yun yung idea natin. So, kapag weak acid, strong base, ito yung mga ginagamit. Bromothymol, bromocresol green, and the methyl orange. Okay. And marami pa kasing uri ng titration talaga, no? So sa lecture ko, I don't know if na-discuss na to sa inyo. There are various types of titration. We have the acid-base, the precipitation, the complexometric, and then the redox, no? So those types of titrations, no? May corresponding pH sila. So depende din sa identity ng acid and base mo, may corresponding endpoint pH sila. So iba-iba kada experiment. But the commonly used is the PHP or the phenolphthalein, the bromocresol green, and the methyl orange, or even the BTB. So, yan yung mga ginagamit. Yung iba, sa ibang uri ng titration yan ginagamit. No? For example, the Aerochrome black tea. Okay, so diniscuss ko to sa lecture ko. So, the Aerochrome black tea is used to titrate complexometric titrations, especially EDTA titration or the ethylene diamine tetraacetic acid titration. So if medyo na-curious kayo dun sa sinabi ko na yun, panoorin nyo yung lecture video ko sa section 1. Okay, kasi bukas pa yung section 13 and section 14 ko. Okay, so yan. So yan, or kung na-discuss naman ng prof nyo, edi good, no? So basta yan. So again, the idea is that depending on the inflection point ang indicator. But there are also other considerations, no, na na pwede nating gawin, no. Kasi iba-iba yung experiments, di ba? For example, look at this graph here. The solid graph or the solid curve is a titration curve for 0.5 molar concentration. And for curve B, ang concentration ay 0.0005. Okay. Ano napansin nyo? Sa curve A, mataas concentration. Sa curve B, mababa concentration. What happened to the curve? What happened? Sa solid line, yung mataas yung concentration, what is the length of the inflection point? Mahaba, no? So, saan siya nag-start? Around dito? Around sa 3? Natapos sa 10. So, ibig sabihin, 7 yung pH gap niya. Halos. However, at lower concentration, what happened to the inflection point? Lumiit siya. Okay? So, nag-start na siya around 5, natapos sa 8. So, 3 na lang yung pH gap niya. So, from 7, naging 3. Ano yung idea dito? Is that at lower concentrations, the inflection point is shorter. And since it is shorter, it will only pass through the color change of some indicators na lang. Ibig sabihin, hindi na pwede gumana yung ibang indicator kapag mahina na yung acids mo. Okay? So ganun. Hindi na gagana yung mga yung ibang indicator kapag yung acid mo ay mahina na. Kasi yung ating inflection point ay umiigsi, no? So for example, ito, yung solid line, pwede mo ka gumamit ng phenolphthalein, bromothymol, bromocresol. Pwede mo yung gamitin yan. However, kapag lumiliit na yung concentrations mo masyado, lumiliit na yung inflection point, that means hindi na pwede gumana yung ibang indicator. Pansinin nyo yung phenolphthalein, wala eh. Post-equivalence na yun eh. So, hindi mo pwede gamitin yung phenolphthalein doon. Bromocresol, hindi. Kasi pre-equivalence point siya magko-color change. Hindi gagana. Pwede mo na lang gamitin is the bromothymol blue. Okay. So again, depending on the length of the inflection point, yung indicator na gagamitin. Okay. So the higher the concentration, the longer the inflection point. That means the more indicators ang pwede nating maging options, no? Pero kapag maigsi yung inflection point, edi onti lang yung options natin. For weak acid, strong base, no? Take note that for weak acids, ang endpoint ay nasa basic pH. So that means you should use indicators that are that will change color in the basic pH, no? Example, the bromothiamol blue and the phenolphthalein. The bromocresol green, ano yung pH range na to? Around 4, ano nga ba? 4 to 6 nga, okay? So 4 to 6 yon, which is acidic. That means hindi mo makikita yung endpoint for weak acid, strong base. Okay? Take note of that. Kapag basic ang transition, no? Pag basic yung endpoint, hindi mo pwede gamitin yung acidic indicators. Also, makikita mo rin dito, nagbabago din yung length ng ating yung length ng ating inflection point as the concentration changes. Yung dash line yung mas mababa yung concentration, mas lumiit siya. Okay? So the higher the concentration is, the longer the inflection point, and the more indicators we can use. No? Okay. So yun yung idea. Also, depende din sa Ka or Kb ang length ng inflection point. No? Okay. Depende yun sa Ka and Kb, yung length ng inflection point. No? So for acids, the higher the Ka, the longer the inflection point. That means mas marami kang pwede magamit na indicator. However, kapag lumiliit lalo yung Ka, mas maliit yung inflection point. Okay? So, onti lang yung indicators na pwede mo gamitin to observe that transition. Ganun din sa bases, no? The higher the Kb, the more it approaches the value of 1, the longer the inflection point. Okay? The lower the Kb, the shorter it becomes. No? Okay, so ito naman, nakwentuhan ko na to last time pero balikan uli natin para ma-refresh. Nabulol na ako. Polyprotic acid-based titration, from the word itself, polyprotic. Ibig sabihin, maraming protons ang involved sa reaction. Either tumanggap ng proton, magbigay ng proton, same lang yan. Polyprotic tawag doon. Pag monoprotic, 1-to-1. Pero kapag diprotic, triprotic, iba na yung ratio or polyprotic. So kapag 2-to-1 or 1-to-2 yung ratio ng protons, then that's diprotic acid-based titration. And kapag 3-to-1 or 1-to-3 yung ratio ng protons, that's triprotic acid-based titration. Okay? So if we have diprotic acid system, a common example done is the sulfuric acid, H2SO4. So you have 2 ionizable hydrogens. So ibig sabihin, diprotic yun. What else? Carbonates. Now, carbonate is a diprotic base. Now, that means it needs 2 hydrogens for it to be neutralized. Now, CO3, 2 minus yun carbonate. Now, kailangan mo ng 2 hydrogen para ma-neutralize yun. Okay? So, yun. Yun yung mga diprotic examples natin. And then we have triprotic example. Isa lang yung common, the phosphoric acid. Okay. H3PO4. That means 3 hydrogens ang protonizable and neutralizable. No? May ganun bang word? Di ko alam pero mukhang tama naman pakinggan. Okay. So ibig sabihin ng 3 yung hydrogens na pwede mo i-neutralize sa phosphoric acid. Okay, so sana gets yan na. This is the titration curve for diprotic acid as I na-discuss ko na to last time. No? Pero let's focus on some details. No? Okay. So sabi ko sa inyo, yun nga. So depende sa dami ng proton ng molecule mo, yun dami ng inflection point mo. Pag diprotic, 2 yung H na manoneutralize. So, 2 yung inflection point na. Take note that na ito, this has a longer inflection point than this one. May meaning yan. Okay? So that means ito, mahaba yung inflection point niya because malaki yung Ka compared to this one. Okay? So ibig sabihin nun, you can use multiple indicators here. However, dito, limited lang yung options mo. Gets yan. Okay? The greater the Ka, the longer the inflection curve. What else now? For diprotic acids, the volume needed to reach the first endpoint, no? Ganon din karami yung volume na kakailanganin mo needed to reach the second endpoint, no? Equal yung dami ng volume ng titrant to neutralize the first and the second proton. Okay? So, kunwari, 10 ml to reach this one. That means 20 ml, marireach mo yan. Gets yan? Kunwari, 15 ml to reach this endpoint. That means, yung next endpoint, marireach mo at 15 ml more. O, ibig sabihin, 30 ml na in total. Okay? Ibig sabihin yan, equal yung volume sa EP1 sa first endpoint and sa second endpoint. Okay? So, ganun. Kunwari, 7 ml to. Ito, 7 ml ulit, no? To reach this one. So, ilan yung total volume? 14. 7 plus 7, 14. Okay? What else? Ano pa alam natin? Halfway dun sa endpoint, ang PHI equals sa pKa. So, ito yung pKa1. Ito yung pKa2. Halfway sa endpoint yung pKa value. So, ito yung pKa1 kasi ito yung first dissociation. pKa2 kasi ito yung second dissociation. Okay? Sana na-integrate nyo yung mga sinabi ko kanina. No? Pinagsasama-sama lang natin yung concept. Okay? So, yan. And those are the equations. No? Yan. And using those equations, you can use equilibrium para makuha yung mga equation na yan. No? Although, for the simplicity of our class, hindi na natin to i-discuss in details. No? Hindi naman ako magbibigay masyado nito. When I say hindi ako masyado magbibigay niyan, siguro isang item lang or dalawa lang. No? Okay. So, magbibigay naman ako ng example sa worksheet. No? So, abangan nyo na lang. Pero don't expect na maraming ganito dito sa exam nyo or sa quiz. Bakit? Sayang oras. Okay. Sayang oras. Ang dami. Okay. So, ang reason is monoprotic lang yung focus natin talaga. Okay. Actually, kahit BS Chem ka, no, hindi mo magagamit ito masyado. Kasi ang focus namin is the monoprotic din. No? Okay. Although we have this din, pero less din. No? Sa inyo, isang item lang siguro, dalawa. Pero don't worry, magbibigay ako ng sa worksheet. No? So, ayan. Take note that at pre-equivalence points, you have the buffer. Okay? Kaya dalawa yung ating pKa na makukuha doon. Okay? And then the rest of the equation is similar with the others then. Okay? So, similar din yun sa iba. Triprotic acid, inflection point 1, 2, 3. So if this use 10 ml, how many ml to reach this? Another 10 ml ulit, no? And how many ml to reach that? Another 10 ml. Okay. So that means the volume for endpoint 1 is the same as the volume for endpoint 2 and endpoint 3. So to get the overall volume needed to neutralize all the hydrogens ay ita times 3 mo lang, no? Okay. So ganun lang. Also, mapapansin nyo rin, the smaller the Ka, the shorter the inflection point. Ito mukhang same lang na pero hindi talaga yan in reality. So this one will be longer than this and this one will be significantly shorter than the others. Minsan nga itong last endpoint di mo na makikita yan eh. Ganun na lang yan. Hindi na siya observable. Kasi maliit lang yung Ka niyan eh. And again, halfway before you reach the endpoint, you will see the pK values now. pKa1, pKa2, and the pKa3. Ayun yung mga important reminders. O kunwari, you know the pKa1, you know the pKa2. Ano yung pH at at EP1, equivalence point 1. Okay, ang shortcut doon is to divide the two. To get the pH of this endpoint, you just you just get the average pala. You average these two pKa values. Tawag dito isoelectric point, which will be discussed din sa biochemistry nyo. Next semester, I think, or next semester. Biochem yan lalabas, no? Yung isoelectric point. So, sana pag na-reach nyo na yung biochem, maalala nyo ako, ay, sinabi to ni Sir. Isoelectric point yan. Again, kapag alam mo yung isang pKa value, alam mo rin to, then if you divide that by 2, makukuha mo yung pH ng first equivalent point. No? Ganun din dito. I-average mo ito, pati ito, makukuha mo yung pH neto. Okay? Tapos ito, calculate mo na lang. Calculate na lang yan eh. Okay. Diba? Wala lang. Galing lang. Okay. So, totoo ba yan? Totoo yun. Galing yan sa equilibrium lahat. So, hindi ko na ibibigay sa inyo yung details kasi hindi naman ako magbibigay na ng triprotic, no? GG talaga kayo dyan, no? Gigil na gigil yung equations. Tignan mo, ang dami. Oh. But take note, tatlo yung ating buffer. Kaya tatlo yung pK values na ma-observe mo dito rin. Tatlo yung buffer natin. Ito, diprotic base. Ito, babalikan natin to sa Lunes. I mean, asynchronous discussion. Wala pa nang pasok sa Lunes. So, babalikan natin to. Ano ganap dito? So, ang ganap dito is that, for example, carbonate. So, it needs 2 hydrogens para ma-neutralize yan. No? So, first hydrogen, second hydrogen. Neutral na siya. Okay. So, mapansin nyo rin, dalawa yung kanyang endpoint. So, kung ilan yung ml to reach this, ganun din karami yung ml to reach that. Okay? So, kung 10 ml to, that means ito ay 10 ml din. Kung 3 ml to, 3 ml din yan. Gets? Then you have two buffer systems here, dito and dito. In the middle, you have the pK values, pKb values. No? Ayan. Yan lang. Yan ang masasabi ko. Kunwari, baka inisip nyo, sir, pwede rin ba dito? Ito plus, no. Ano nangyari? Siguro inisip nyo, sir, pwede ba ito and ito, divide ko yan, makukuha ko to? Yes. Pwede yun. Ano rin to? Isoelectric point din to. Okay, so isoelectric point will be discussed in biochem na lang. Okay. Next year nyo na lang yan. Okay? Ayan. So, yan. And these are the equations. Dalawa buffer systems natin. Take note. Okay. So, yan. Lahat ito galing yan sa equilibrium. Okay. So, yan. Next, saka na to. Okay. So, sa susunod na meeting, ito yung discuss natin. Ayan. Ito. Pinakita ko na dito yung graph with the endpoints. Kung to pH 8 to 10, ayan, magko-color na siya. Bromocresol green from green to yellow. Ayan. Mapansin nyo, for sodium hydroxide, it reaches this pH values, no? So, tumatama siya dito. Actually, pangit pa tong curve na nagawa ko. Dapat kasi ganun agad yan eh. Steep yung pagkababa niyan. Siyempre, ang hirap mag-PowerPoint din, kaya ginanyan ko na lang. Pero the idea is, ito, inflection point yan, starting dito. Tatamahan niya dalawang inflection point kasi siya ay strong acid. Sa carbonate, ganon. Yan. So, tatamaan niya to. Ito yung first endpoint niya. And then the second endpoint. For sodium carbonate, no? So, hindi niya matatamaan yung phenolphthalein endpoint. No? Only the BCG endpoint kasi acidic yung endpoint nun. Di-discuss natin to next meeting kasi ano yung application nitong discussion natin dito. Application nito ay kunwari gusto mo malaman gaano karami yung components ng detergent mo, pwede mo gamitin to. Okay. Kung gusto mo malaman yung components ng limestone, no, yung mga limestone, pwede mo gamitin tong titration. Okay? So, ang experiment namin dito ng undergraduate, bumili kami ng Pride, ng Ariel, no, ng Breeze, no, lahat ng mga powder. Tinitrate namin yun. Nakakatawa eh. Sayang, hindi nyo na-experience yun ngayon. No? Pero anyway, hopefully ma-try din natin yun sa lab in the future. Okay. So, yan. With that, tapos na yung ating discussion. So, do you have any questions, queries? No? Wala pa naman. Okay. So, ganito. Dalawa yung quiz natin sa topic na to. By next week, magbubukas ako ng isa. No? Isa lang muna. Okay. Then, yung pangalawa to follow na lang. Okay. So, yan. Yan. So, tapos na tayo sa computation part ng monoprotic. And yung susunod na lang is, etong isa na lang. Ito na lang. Acid-base mixture. Madali lang yan. Logic nga lang. Medyo confusing yan at first pero pag tama yung logic mo, goods tayo dun. Okay. Madali lang yan. Okay. Logic lang. Ano po coverage ng first quiz? Usually hinahati ko to sa dalawa, diba? Bali siguro for the first quiz, ito yung aking isasama. Nag-iisip din ako, ano kaya mga pwede isama? Siguro ito na lang muna. Yan. Ang mga basics muna, ito na lang yung sa quiz 1. Then ito yung sa quiz 2. Kasi ito yung diniscuss natin. Ay, nawala. Kala ko nakikita nyo. Yan. So ito sa quiz 1, ito sa quiz 2. Hanggang strong SASB, SBSA lang yung quiz 1. Then susunod is yung mga weak sa quiz 2 na lang. Okay. Itong indicator, siguro pwede ko rin ilagay yun doon. No? Pwedeng meron din dito. Madali lang naman eh. Color lang naman yung kailangan mo alalahanan. Okay. So, yan. Ayan. And again, 2 attempts tayo ha. 2 attempts para yung mga mabababa, yung grades ng nakaraan, makabawi na. Kailangan bawin-bawi ha. Okay. So, hopefully, makabawi talaga tayo. Okay. So, with that, bukod sa scores, no, sana may natutunan tayo. Madali lang kasi kunin yung score basta alam mo yung lesson. And hopefully, natutunan nyo yung lesson today. Okay. So, if you have any concerns, you can let me know na lang. Sabihin nyo na lang sa akin. No? Okay. So, yan. Kung gusto nyo mag-download nito, punta lang kayo sa Casio website. No? Kunwari, wala kayong calcu. Ganito lang gagawin nyo. Noong nakaraan ko lang ito ginugol eh. Casio calculator PC download. Diba? Type niyan, Casio calculator PC download. Kapag MacBook kayo, di ko alam. Mahirap lang ako. Kaya ito lang Windows ako. Tsaka mas madali mag-Windows. No? So yan, dito select nyo lang to English at download scientific calculator tas English. Tapos yan, mapupunta kayo dito sa website na to. Ito na lang pala. Paikot-ikot pa. Search nyo yan, educasio.com. edu.casio.com/dl. Just click nyo to. Tapos yan, mamili kayo ng software. Pwedeng Mac, pwedeng Windows. Windows ako. And download. Ayan, maraming versions. No? Pero ang i-download nyo ay ito. ClassWiz. class Wiz or itong FS. Pero mas maganda class Wiz na lang. Okay. So, select nyo yung model o 570 or 991. 991 yung dinownload ko dito eh. Download. Free trial lang to for 90 days ata. Do pwede nyo rin bilhin, 700 pesos lang daw. I'm planning to buy this kaso 1 year lang siya. So naghahanap ako ng pirata. Yung nagtitipid talaga eh, no? So ito yung single license 1 year. 700 lang. Okay. Makalang, kala mo, ang dali lang makuha yung 700 din. Okay. So yun, with that, no? Hopefully natutunan nyo. And sana kung wala kayong calcu, download din kayo nito, ha? Laking tulong to sa atin. Okay, so with that, thank you for attending our session. Hopefully may natutunan, ha? So I'll see you again next time. So async muna tayo next sa last topic na ito. Okay? So with that, bye-bye and ingat. Okay? Ano pa ba sasabihin ko? Ayun lang. Basta mag-ingat lang muna, ha? Okay, so bye-bye.